Hi, buddy. Welcome back to another calculus practice video. Here we're going to estimate the derivative of e to the x using the power series method. Here we can prove exactly why f of x is equal to e to the x and f prime of x is equal to e to the x as well. That should be our end goal. Here we can use it using a power series, which is an estimation of our special functions using polynomials. I'm not going to get into them very much right now, but all that we know is centered at 0, e to the x is equal to this sum. And what this sum actually means is if we plug in n is equal to 0, then 1, then 2, and 3, and we add all the results together out to infinity, it will estimate e to the x. So when n is equal to 0, we'll end up getting x to the 0 divided by 0 factorial, which is just 1, plus when n is equal to 1, so we'll get x to the 1 divided by 1 factorial, which is also 1, and so on. We'll get x squared divided by 2 factorial. We'll get x cubed over 3 factorial, and so on, all the way out to infinity. Now, or we just use this really cool method where we take the exponents and we multiply it and then subtract by 1, right? So if we actually do that for whenever f of x is equal to e to the x, f prime of x, again, if we use this in the polynomial form, the derivative of 1 is 0, so it just goes away, right? The derivative of x becomes 1. The derivative of the next term is going to be 2x divided by 2 factorial, and so on. 3x squared divided by 3 factorial, plus 4x cubed divided by 4 factorial. I made that mistake up above, so I hope you have caught that. And so on out to infinity. Now, the cool thing is when you have 2 divided by 2 factorial, 3 divided by 3 factorial, 4 divided by 4 factorial, what this will end up simplifying is going to be x over 1 factorial, which is just 1, plus x squared over 2 factorial, plus x cubed all over 3 factorial, and that repeats out to infinity as well. And the reason why is because we actually have the form, if let's say we have 3 over 3 factorial once again, what 3 factorial actually means is equal to 3 times 2 times 1. And if the 3's cancel out, it's the same thing as saying 1 all over 2 factorial. And the same thing with 4 over 4 factorial, 5 over 5 factorial. It just basically reduces the factorial by 1 digit. And it cancels out the top term in the numerator. So here, this actually just proves that f prime of x, when it goes out to infinity and expanded out to an infinite number of terms for the sum, is just going to be e to the x as well. This is the whole proof that shows that the derivative of e to the x is just e to the x as well. I hope you have learned something here today. Have a great day.